as you can see, I'm still around. Okay, so this is a lecture on Ekman layers and geostrophic flows. Okay, it's not so easy. Okay, so this one is one of the trickier lectures. So let's have a look at the content. Okay, so what is a force and what does it do? Okay, so classification of forces in the ocean. You learn about the dynamical structure of the oceans. Okay, you learn about vertical shear flows and the Coriolis force. There's one type of features in the ocean which is known as inertial oscillations. What are these inertial oscillations? When we talk about frictional boundary layers, they are called Ekman layers. Okay, there's a surface Ekman layer and there's a bottom Ekman layer. We talk about the pressure gradient force. Okay, you already learned about the pressure gradient force to some extent, but only in the vertical direction. And now we're talking about horizontal pressure gradients. What do they do? Because they create something that we call the geostrophic balance. Okay? And I'll give you examples of geostrophic currents. Sounds hard, but in the end, if you think about it, it actually turns out to be really easy in a sense that you can actually predict ocean currents, and you can even derive ocean currents from measuring temperature and salinity. It's hard to believe, but it's really true. You can really do that. And most currents in the ocean are also horizontal. So it's much easier than to predict the movement of cream in a coffee cup if you mix the coffee cup. All right.